All right, we have 2 lessons left. So this one is 7-4, double angle and half angle identities. Okay, if you want to look on page 448 and 449, there's a proof for where these identities come from. But here they all are. The thing to note is that cosine does have 3 identities. So they're right there. Sine has 1 commonly used, tangent has 1, but the cosine ones, there are 3, so you get to pick. Okay. Right into examples. It says if sine of an angle equals 2/3 and the angle has its terminal side in the first quadrant, find the exact value of each function. Okay, so sine of double this angle. So if you look at the sine double angle formula, we need to know what cosine of the angle is. So we're going to use the fact that sine squared theta plus cosine squared theta equals 1 to figure out what cosine is. Okay, so we got 4/9. Okay, move 4/9 over. So this would be pretty much 9/9 minus 4/9. So cosine squared theta equals 5/9. Now we're going to square root both sides. So cosine of our angle is going to equal the square root of 5/3. It tells us that it's in the first quadrant, so we know that sine, cosine, and tangent are all positive in the first quadrant. So cosine of our angle is going to be the square root of 5/3, and it's going to be positive. Okay, so now we're going to plug it into this equation up here. So sine of the double angle is going to be 2 sine of angle is 2/3. Cosine of the angle is the square root of 5/3. Okay, now we just solve. So we have 4 square root of 5/9, and that would be our answer. All right. We'll come back to this one over here. So the next one we're going to do is cosine double angle. Okay, so we can pick which one of these we want to use. We can use any of them we want. We'll just use the first one. We already know what cosine and sine are. Okay, so we're going to say cosine of double angle equals cosine squared minus sine squared. Okay. So cosine squared is going to be the square root of 5/3 squared minus sine squared, which is 2/3 squared. So that's going to equal 5/9 minus 4/9, which equals 1/9. So that's our answer. Done. Sweet. Okay, let's work on the tangent one. We have only one over here, but we don't know what tangent of this angle is. So tangent of the angle equals sine of angle over cosine of the angle. Okay, so we need to find what tangent of the angle is going to be. Sine is going to be 2/3. I'm going to just say divided by the square root of 5/3 so that I can flip my second one and multiply. Okay, so we have 2 over the square root of 5. We don't want to have the square root of 5 in the denominator. Okay, So we can get rid of that by multiplying by the square root of 5. So that's going to be 2 root, whoop, of course, forever off the page. Okay, 2 root 5 over 5. Okay, that's going to be our tangent of the angle. So now we're going to use the tangent equation. I'm going to give myself a tiny bit of room for the one above. So tan 2 of the angle equals 2 tan theta over 1 minus tan squared theta. Okay, so here's tan. So I'm going to do 2 times 2 square root of 5 over 5. I'm going to divide that by 1 minus 2 square root of 5 over 5 squared. Okay, I'll work this way for a second. So now I'm going to have 4 square root of 5 over 5 divided by 1 minus 4 times 5 over 25. Okay. So this will be 4 root 5 over 5 divided by 20 over 5. 20 over 25, which is 1/5. No, it's not. That's 4/5. So 1 minus 4/5 equals 1/5 over this. Okay, so now I'm going to do one of my divided by 1/5. So we could flip it. Those go away. So our answer is going to be 4 square root of 5. All right. I think that the double angle formula tends to be a little easier. Okay, so this last one, this is the same as saying cosine 2 of that, right? Okay. So once we know the angle, it's just saying like double that angle. Okay, so we're going to use the double angle of cosine. Okay. All right, so we're going to use that cosine square root of theta minus sine square root of theta. Okay, but remember that this is actually going to be 2 of them because of this right here. We actually have 2 of them twice. Okay, so what we're going to do is we're going to take the answer to 2 theta, which cosine 2 theta was 1/9. So we're going to say 1/9 squared. So now we're going to take it of sine 2 theta. This is sine 2 theta, which was the 4 square root of 5 over 9 squared. Now we're going to simplify. So I'm going to have 1/81 minus that. Okay. So 16 times 5 is 80. So I'm going to have 1/81 minus 80 over 81. So I'll have negative 79 over 81, and that's our answer. Okay. All right. Next, we're going to talk about our half angle identities. The half angles are on page 450 to 451. Okay. The thing with the half angles is they have these plus or minuses in the top. You're going to have to figure out the quadrants based off of the information given to you. Okay, I'll show you what I mean by that. These ones have kind of an extra little step, so they can be a smidge-widge confusing. Okay, so use a half angle identity to find the exact value of each function. Okay, so this is sine of 7 pi over 12. Well, we're going to want to use our sine. Okay. The first thing that we are going to do is, in order to figure out what this alpha is, okay, what we're going to do is we're going to say this place is in the same part as this place. So I'm going to say sine over 2 equals 7 pi over 12. Okay. Multiply both sides by 2. So then this will reduce. This is a 1. This is a 6. So alpha is going to equal 7 pi over 6. So really what this is saying is sine of 7 pi over 6 divided by 2. Okay? Because this is actually equal to this. Right? Now we are going to use our sine equation here. Okay. So that equation is the square root of 1 minus cosine 7 pi over 6 divided by 2. Okay. The next thing is we need to figure out whether we're going to use the plus or the minus of it. So how we're going to do that is we're going to figure out at 7 pi over 12, what is the sine of that angle going to be? Well, it's going to be more than half of a pi, because that would be 6 pi over 12. So we're in quadrant 2. A sine in quadrant 2 is a positive value. You can look at your unit circle. So that means that this is going to have a positive value. Okay. If it was in one of the areas where sine was negative, then we would have a negative out in front. So now what we're going to do is we are going to reduce. Okay. So what we're going to do is do math. Okay. So cosine of 7 pi over 6, use your unit circle. You'll find out that that is negative square root of 3 over 2. So now we want to add these together. This would be the same as 2 over 2 minus minus plus. So that would be 2 plus the square root of 3 over 2. Divided it by 1/2. We could flip that. So we would have, this needs to be in the square root. So we would have, that goes away. So we would have the square root of 2 plus the square root of 3. And that would be your answer. No, that would not be your answer. Okay, now I need whiteout. This is the one time. Oh, that's why I made a mistake. Okay. So I'm going to go like this. Are you ready? Actually, I'm going to get a sticky note. I'll be right back. All right, I love filming and I hate filming because sometimes when I make a mistake, I can't erase it because I have to use a pen because you can't see it. Okay, so equals, let's try it again. So we have 1 plus the square root of 3 over 2. We're going to put that in a square root. Over what is going on? Oh, no. Okay, in order to be able to combine these like terms, I made this 2 over 2, right? Which equals the square root of 2 plus the square root of 3 over 2. And then all of that is divided by two. Okay. All right. Whew, I got it. No worries. Okay, so when we flip and multiply this, we really would have 2 plus the square root of 3 over 2 times 1/2, which equals 2 plus the square root of 3 over 4 square rooted. The square root of 4 can be square rooted, so we'd have 2 plus the square root of 3 over 2. Woohoo! Hey, and then this is my answer. Be really careful with your roots. Here you go. Okay. All right, I'm going to scoot this over a smidge so that I can use the cosine equation. Okay. All right. So same thing over here. I need to do alpha over 2 equals 67.5. So that means that alpha is going to be equal to 2 times 67.5. That's 135. Okay. So when I write it in my cosine equation, okay, I'm going to write cosine of 135 divided by 2 equals this. So 1 plus cosine of alpha over 2 square root. Okay. Now I need to find out whether my alpha was 135, so I could actually put that in. Okay, now I need to find if it's going to be a plus or minus. Well, 67 degrees is going to be in quadrant 1, so that means it's going to have a positive value, so we'll just put a plus so I remember. Okay. So now we just need to solve. So 1 plus the cosine of 135. So we need to figure out what 135 is, which you can do in your unit circle, and it's going to be the negative square root of 2 over 2. Okay, back to all of my calculating. Let's start over here to give ourselves room. So we're going to do 2 over 2 plus negative square root of 2 over 2, all of that over 2. So the top is going to be 2 minus the square root of 2 over 2 divided by 2. Okay. But when we divide by 2, oh, it's all in the square root. But when we divide by that 2, we're going to really flip and multiply. So what we're going to have left is the square root of, let's see if I have a little room left there. 2 minus the square root of 2. When we flip and multiply, that becomes the 4 again. So then we'll have the square root of 4 is 2. and that's our answer. Okay, so you have to just be really careful with your roots on these. All right. Now my boo-boo note. Let's cross that off right here. I think I was actually on the right path, but that's okay. Take the sticky back in a minute. Okay. Verify that this is an identity. So using our identities and the information we know, we can use half angle and double angle formulas to verify our identities. Okay. Get the papers to stop moving around. All right. Okay. So we're going to start by, I'm going to draw my line just to remind me not to move things. I'm going to start on this side with the cotangents and try and manipulate those to see if it'll end up being anything like this, okay? So cotangent is cosine of theta over sine of theta minus 1 all over cosine of theta sine of theta plus 1. Okay. Now what we're going to do is we're going to multiply by sine of theta over sine of theta. Okay, what that's going to do is do sine of theta times this. We'll make that sine go away. So I'll have cosine of theta minus sine of theta over, same thing, that's going to go away. We'll have cosine of theta plus sine of theta. We are going to see right here that I'm going to check something out to see what I'm seeing. Okay. So what this is telling me that I can do is I want to get the top to be cosine 2 theta, and cosine 2 theta is the same as cosine squared sine squared. Okay, so what I'm going to do is I'm going to multiply everything by cosine of theta plus sine of theta, because that'll actually get our top to what we want it to be. Okay, so now I'm going to have cosine squared theta. So I'm going to have a minus, so cosine sine theta minus sine cosine, okay, plus sine cosine, so those cancel out, minus sine squared theta over cosine squared theta plus, now I'm going to have 2 sine theta cosine theta plus sine squared theta. Sweet. Okay. All right. So once I multiply, now I can simplify. So the top there we said is the same as a cosine double angle. Hot dog. All right. 2 sine theta cosine theta is actually the same, if you remember looking back, as so now hold on, I'll just move stuff around so you can see. I'm going to move these together. All right. What is cosine squared theta plus sine squared theta? These two equal 1. I'll do that. These equal 1. Okay. And this beauty equals sine double angle. Okay, which if you, okay, so that's what the bottom is reduced. I shouldn't put that there. So that means I have left is cosine 2 of the angle over 1 plus sine 2 of the angle, which is what we started with, and that was our goal. Okay. So check, they work. All right, homework. Page 454, number 17 through 47 odd. Please let me know if you have any questions. Have a wonderful week, and next week we only have 7-5. Whoopee!